Okay, I'm gonna maybe do a couple more minutes, about another minute or so, see if anybody else is gonna come in. I am going to record the session tonight, so that I can put it up on YouTube, and I will get that link provided to you guys as soon as I have it up, and running. And I do apologize for not having class tonight. We just had some stuff come up and there was just no way that I was gonna be able to be on campus. So I just decided that a Zoom meeting would be the most effective way for us to handle this. Everybody should be able to get in as this is going, but I am going to go ahead and use the most efficient use of our time and make sure that this is, run, and I'm respectful of y'all's time as this is processing. So we are covering section 2.6 tonight, along with 2.7 and 2.8. 2.6, we're going to talk about combining functions and also doing composite functions. Doing composition of functions is where you're putting kind of one function inside of another function. I will go ahead and add as a side note, if you have a question, please utilize the chat feature. And I will try to make sure that I am watching the chat to see if I've got any questions coming up. I did try to watch that pretty closely to make sure that I can answer any questions that may be coming up as that's processing. So like I said, we're going to start with combinations and composition. 2.7, we'll be talking about inverses, which is undoing things, and what one thing does, an inverse undoes, and how to talk about those. And then section 2.8 is going to be a couple of small little things, distance formula, midpoint, and some stuff with circles and things of that nature. So we're going to go ahead and get started with section 2.6. And the first thing we're going to talk about is combinations of functions. So we will talk about the domain of a function, because when you start to combine functions, we do have to be mindful of values that cannot be used within the context of a problem, because they lead to undesirable values. We've seen before where if we have square root of negative, we don't like that because it brings in that I, and it brings in that complex or imaginary type stuff. And so we really don't want to see that kind of thing happening. So we really have two main types here that have issues. The first one is rational functions, and rational, as we talked about last week, we saw it as a rational exponent. Rational just means fraction. And one of the things that we have issue with is the fact that you are not allowed to divide by 0. So we cannot let the denominator of a fraction be equal to 0 as a value. So any numbers that might make that happen, we need to go ahead and eliminate them out of the domain, or things that we would be looking to be using. The second one is the square roots, as I mentioned previously, because we don't want there to be any sort of imaginary numbers coming up into play. And so we don't want to see that happening. So we're going to take a look at an example here. We've got 5x over x squared minus 49. I'm going to go ahead and transfer this over here onto this. I will make this whiteboard bigger here in just a second so that you are able to see it. Okay. I will make that bigger. So give me just a second. I'll make that happen.
You're on mute.
There we go. Okay, sorry. Maybe that'll fix. Sorry, I forgot to hit a button. So we don't want x squared minus 49. We do not want that to equal 0. So what we're actually going to do is we're going to set it up and say that that can't equal 0. And we're going to process this the same way that we would as if it were an equal sign. So I'm going to add 49 onto both sides. Sorry. Okay. And then same thing as we've done before, we're going to do square root. Okay. So I'm going to do square root on both sides. Again, those two cancel out. And same way as before, we brought in the square root, which means we're going to bring in a plus and a minus. Now we can take a pretty square root of 49, so that's going to be 7. Now, there's a couple of different ways that you can write the domain for this. So one is we do just say x can't be -7 or +7. So we just kind of list and say, hey, these are the numbers that are off limits for what's going on. If they're trying to write this in an interval notation, these are the only two numbers that are off limits. So we would have -∞ to -7 with an open parenthesis on it, saying that we're not actually using -7, unioned with -7 to 7, and then union with, I kind of ran out of room over here, 7 to infinity. So basically we're using the unions here to show and kind of jump over the values that we're not able to use. Okay, so I'm basically going everything up to -7, skip over -7, pick up back on the other side, go up to regular 7, skip over that, and then out to 7 again. We would see a similar idea, and I'm going to make up one here real quick for the square root stuff. So if I had something like square root of 2x plus 5, okay, and this was my function, I want to make sure that this is not negative. So for this scenario, we are okay if 2x plus 5 equals 0, but we would like it to be like that's as low as it can go. So the way that we would handle this one would be, we would set 2x plus 5, and we want that to be greater than or equal to, we're fine with that, 0. And now we're going to solve this the same way that we did traditional inequalities way back over in section 1.7. So I'm going to subtract the 5. Divide by 2. Remember that it's only if you multiply or divide by a negative number that you're going to flip the symbol. So for this one, I would have that x needs to be greater than or equal to -5/2. Okay. In an interval notation, this would look like -5/2 to infinity. Since we do want x's to be greater or larger than that, that would be the lowest side value that would be happening on that side. Let me jump back to our PowerPoint here. Okay, so now then, when we talk about combining functions, okay, they make this sound really a lot more complicated than it really truly needs to be. Very similar to how we did when we did operations with complex numbers. You kind of followed your instinct. That's the same thing that's going to happen here. So when we add functions, it's really going to feel like you're combining like terms. With subtraction, we're going to have to make sure that we very carefully watch that subtract symbol. If it's getting moved through, we are going to be using parentheses here to help keep things clustered. Multiplication is again going to feel like some foiling or multiplication type stuff with a lot of distribution going on. And then division, oftentimes with division, there's not a whole lot you can do other than set it up, but you do have to make this statement down here that g of x cannot equal 0. That's kind of a big deal because you now have created a fraction, and we want to make sure that we're not equal to 0 on that denominator. So we're going to be working with the same set of equations. So I'm going to put them up here at the top of our board again. And again, I'll switch over here in just a second so that you can see this a little bit bigger. And they're going to want us to go through, and we're going to do add, subtract, multiply, and divide. And we're also going to talk about the domain for each time that we actually do that process, okay? So now the first thing to note on this one is that x minus 5 is a linear function. There is nothing in its domain. I don't have a fraction. I don't have a square root. I don't have anything that has any sort of problem that would create an issue with this. So I don't have anything off limits in this one. X squared plus 1 also does not have any limitations to it. So both of these have a domain that is currently all real numbers. There's nothing off limits for it. So if we're going to do f plus g of x, okay, and again, I'm going to use parentheses here, more so as a grouping symbol to make this happen, okay? So I have x minus 5 plus x squared minus 1. Cleaning this up and putting it in a more traditional order of highest powered things first. I've got x squared plus x, and then I'm going to combine the minus 5 and minus 1 to make a minus 6. Now, again, with this outcome, I don't have anything that's created a square root. I don't have any fractions. I don't have anything that has an issue. So my domain is still going to be all real numbers. And remember that that double scripted R is the thing for all real numbers. Okay. So now we'll look at subtract. Now, thing to note is if they had put G minus F, then I would have written G first and then F. You just follow the order that they put the things over here as you're processing through. Now, with this one, we are going to have to make sure that we watch how this subtract or this negative distributes into the line. So I've got x minus 5, and then I'm going to have negative x squared plus 1 for that one. And again, okay, putting things kind of in order here, we're going to have negative x squared plus x, and this time I've got a negative 5 plus 1 is going to be negative 4. I'm trying to get that out of that glare dot. Okay. And now, once again, with this answer, this result that we have, there's no square roots, there's no fractions, so there's nothing that's off limits. So we have a domain that is still all real numbers. Okay. So I'll leave that there. I'm going to try and scooch just a little bit. So now I'm going to try and avoid that big glare dot that I have in the middle. So now we're going to do multiplication. So I'm going to have x minus 5, x squared minus 1. And this is going to become a FOIL or a multiply type problem. So I'm going to get x cubed minus x minus 5x squared plus 5. Again, if you want to clean that up just a bit to get it in that kind of highest powers working your way downwards. We would have x cubed minus 5x squared minus x plus 5. Okay. And again, no square roots, no fractions. So this is still okay on its domain, meaning all real numbers. Okay, so a lot of this is still going to be just following your instinct and following how this is going to process. Okay. Okay, so let's look at the division one. I'm going to have to get rid of some of this. I'll come back up here. And again, I am recording this session and it'll be on YouTube as soon as I can get it downloaded, processed, and then reworked up. So if I'm going to do F over G, then I'm going to do X minus 5 over X squared minus 1. Okay. Now, we do have the stipulation in this one, and we already see it happening here. I do now have a fraction, so I've got to make sure that my denominator, okay, so the X squared minus 1, that's not allowed to be 0. So I'm going to do X squared minus 1. Can't be 0. We'll add that 1. We'll take a square root. So we're going to have x can't be plus or minus square root of 1 is 1. So we would add the stipulation up here. X cannot be -1 or +1. So this is an added stipulation. Also, it already came up because we did all of a sudden have a fraction that is created. And so we've got to make sure that we bring that into understanding, that you bring that into consideration and make sure that that denominator cannot equal 0. Now, separate side note, okay? Let's say, for example, that you had your f over g of x, that you had something like x plus 2 over x plus 2, x minus 3, okay? Where you would, in fact, be able to cross out this x plus 2, x plus 3, or sorry, x plus 2, x plus 2 over here that would cancel off. That's fine, but you still have to make the declaration that x plus 2 cannot be 0, which means x can't be -2, and x minus 3 can't be 0, which means x can't be 3. So I still have, even if I clean this up, and I have 1 over x minus 3, which is a prettier format, I still have this cannot be -2 or 3, because the way that the division statement is phrased, it says that the entire original, which would be this entire thing down here, that entire original g of x cannot be 0. Not a modified, not a reduced, not a cleaned up version. The entire original g of x denominator is not allowed to be 0. Okay, so we just have to kind of keep that in mind as we're processing. Okay, so let me get back to our lovely PowerPoint here. Okay, so we did add. We've done subtract. There's our multiply, and there's our divide. Okay, so now what we're going to look at is composition. Okay, now then, with composition, you are quite literally taking one equation and putting it inside of another equation. Okay, so let me give you an example of this real quick. I'm going to come back to our whiteboard here for just a second. Okay. Let's say that you were in the market to go purchase a new vehicle. Okay, and that there were two main discounts that were being offered. So the first one at the dealership was that you were going to get a 10% off of the price of the car, that this was some sort of rebate, whatever else they were going to be allowed to do. The other one is that they were going to take $3,000 off as well. And this may have been some sort of like dealership incentive, year-end closeout, things like that were going on. Now, the question becomes, does it matter which order I do the discounts in? Okay, so let's take a look. I'm going to pick a nice, pretty number. We're going to talk about a $20,000 vehicle. Okay, so if I do the 10% off first, that is going to be $2,000. So we're going to have 20,000 minus the 2,000, and that's going to give us 18,000. Okay, and then secondly, I'm going to do the $3,000 off. So I'll take another $3,000 from here, and that's going to put us at 15,000. Okay, so that's option number one. Now let's look at it if they do it in reverse. So again, same $20,000 vehicle. Let's start with the $3,000 off. So we're going to start with that $20,000 vehicle again. We're going to take $3,000 off. That's going to put us at 17,000. Then I'm going to do my 10%, which is $1,700. and I wind up with $15,300. Okay. Now, this is kind of inherently what we occasionally see happen. Okay. There was a time when I was trying to purchase a new truck, and I had two dealerships that I was kind of having them each work the price of a truck. And I had kind of the same scenario happening. I had one dealership that could get it down to a certain price, and the other was off by about $400. And the one that was higher indicated that they had no clue what discounts I was getting, how they were able to make it so that they were cheaper. And it had nothing to do with the discounts, because the discounts are fairly universal. It had everything to do with the order that the discounts were done in. And so what had happened is the dealership that was cheaper had done a percentage discount first. And because that percentage discount was being done on a higher value, it was a higher amount off. And then the later on, whereas here, because they took the $3,000 off, by the time that percentage hits, it's on a smaller valued item. But there's this idea that if these are my two discounts, what if instead of a $20,000 vehicle, I wanted to look at a $30,000 vehicle or a $45,000 vehicle or any other price? What I don't want to have to do is go through this kind of two-step process of finding the answers as going on. So what a composition will allow me to do, composition will allow me to come up with one equation that will handle all of this, to where if I put in 20,000, it outputs 15,000. If I put in 30,000, it would output what that's going to be. If I put in 45, it'll output whatever that's going to come out as. Okay. Okay, so notationally, what's happening here, okay, is when you talk about F composed with G, okay, and I know it looks kind of like the word fog, and oftentimes we do talk about doing fog. It's this little circle, okay, and the first thing that I actually do is I get out of that little circle dot notation and into this F parentheses G parentheses X notation, okay, it's a little bit helped out. Now, as far as the domain goes, it's a little bit easier to handle this once we've actually created our functions as this is going through. And then we'll also talk about excluding some values. So we're going to look at a couple of options here for how to do this. So our first example is going to be this. So I'm going to have f of x equals 5x plus 6. G of x is going to be equal to 2x squared minus x minus 1. And they want us to find f composed with g of x. Okay, so I'm going to come back to our lovely whiteboard. Here we go. Okay, so again, the first thing that I said is I'm going to move over to this f of g of x. Okay, now what I'm fixing to do, and I'm going to use a little bit of color here to help us out. Okay, one of the things that you should see is we see this g of x right here in the smack middle, but I know what g of x is. So I'm going to do f of, I'm going to write this in another color just so that we can keep track of where everything's going. Okay, so we've got this. Now, the concept here is, okay, and I'm going to use this lovely red glasses pack here for just a second, okay? If this was f of 3, okay, you would tell me that everywhere you saw an x up here in f, you would put a 3, okay? Switch things here. Try to keep, because I don't have another red one. So I'm going to use a gray one, this gray, okay? You would say that everywhere you saw an X, you would put a 3. So the concept here is I'm going to do 5, a set of parentheses, and I'm going to put that gray right there, plus 6. So everywhere that I see, so I'm doing 5 glasses cleaner, okay, f of glasses cleaner is 5 glasses cleaner plus 6. Okay, so again, I'm just doing some blocking here so that we don't get caught up in the notation, okay? So now, whatever is under my glasses cleaner, I need to bring down into this other spot. So I'm going to be bringing in a 2x squared minus x minus 1. Okay. We can clean that up just a little bit by distributing. So now I have 10x squared minus 5x minus 5. And then I still have that plus 6 from the end of the line. And then we can combine on the back part, and we get 10x squared minus 5x plus 1. Okay. And so that is my composition right there. That is f composed with g of x. Now, you are able to do the other direction. Okay, so I am going to go ahead and show what that other composition looks like, just so that you can see where this is going to go. Sometimes one direction is a little bit simpler to calculate than the other one. Sometimes they're about the same. So what I'm now going to do this. Okay, is now I'm going to do g composed with f of x. And again, first thing that I'm going to do is I'm getting out of that composition dot notation and into that set of parentheses. Okay. So again, I see that f of x right there in the middle. I'm going to replace the f of x with exactly what f of x is. So I've got 5x plus 6 okay. Now, same game. Cover that up. Okay. So now, when I'm looking at my g of x, this is going to be 2 squared, that's my glasses cleaner, minus glasses cleaner minus 1. So again, talking it through kind of, quirky weird. G of glasses cleaner is 2 glasses cleaner squared. So 2 glasses cleaner squared minus glasses cleaner. So minus glasses cleaner minus 1. And then I've got my minus 1. Okay. So now whatever was up here underneath my glasses cleaner here, I need to replace in. Okay. Now, this one is going to be a little more involved because I am going to need to square this. Okay, so I'm going to have 2 5x plus 6 times 5x plus 6. I am going to go ahead and distribute my negative here. So it's going to be minus 5x minus 6. And then I've got that minus 1 out at the end. Okay. Multiplying, I'm going to get 25x squared. It's going to be 30, so it's going to be 60x and plus 36. And again, I've still got the rest of this. I'm going to multiply that 2 through the line. So I'm going to have 50x squared plus 120x plus 72 minus 5x. And I could have already done this before, but I do need to go ahead and make that a minus 7. Just combining those back to back. Now I can do a little bit of combining here with my x's and with my numbers. So I'm going to end up with negative 50x squared plus 115x plus 65. Okay. Now, notice that this is a different answer than what we got when we did f composed with g of x. There is not an expectation that I would get the same thing, the same way as I did with the car example, and that you did not get the same value after you did that with the 10% off and then the 3,000 versus 3,000 and 10%. I don't anticipate getting the same response when I do g of f of x as opposed to getting f of g of x. Okay, so I don't anticipate having the same responses as that goes through. So let's go back to our PowerPoint here. Okay, so let's take a look at another one. Now, this one, they do want us to talk about, oh, excuse me. Let me go back to the previous of what we were doing, okay? Notice here in this composition, okay, and also the one we had on the other one was also just a straight polynomial type thing. There are no issues with this, okay? There is nothing that is off limits. There is nothing that we have. So the domain for this one and also the one where we did f of g of x would still be all real numbers. Now, the example that we're about to look at is going to be a bit different because it is going to bring in some equations that do have issues for us, okay? And so the way that I deal with those is we kind of deal with it as we're processing through the problem, okay? So again, I'm going to get this marked on my whiteboard, and then we'll come, and then I'll bring that whiteboard back up so you guys can see it kind of large, okay? And they want us to do f composed with g on this one. Okay, so here's what we've got. Okay, this loveliness. Now, again, first thing is they want to do f composed with g. First thing again is going to be getting out of that notation. Can somebody tell me, am I still muted? I know Kim told me earlier that I was muted. I hope that I fixed that.
I can hear you.
Okay. Okay, so we're back. I still haven't completely figured out all this lovely Zoom stuff. I try. Okay, so I'm going to start the same way that we had before. Here's g of x. So I'm going to plug in my g of x notation. Plug this in. Now, right now, I have a problem because I have a fraction. Awesome. Thank you guys so much for letting me know. So I've got this. Right now, I've got a fraction involved. So just off the jump right now, based on the fact that I've already put in a function that I have a problem with, I need to know right now, x, which is the denominator of this thing, cannot be 0. So now I've already established, and there's nothing else I need to do with that, 0 is a number that's going to be off limits for this problem. Okay, so now I'm going to do the same thing, though, okay, that we were playing with before. So again, I'm going to do the little cover-up game here. Okay, so I've got f of, again, glasses cleaner. I'm going to come down here. So this is going to be 4 over glasses cleaner plus 2. Okay, so again, whatever's under there, we're going to transfer in. So again, we're doing that same concept. So whatever's underneath my glasses cleaner, I'm going to now put in. Okay, now in looking at this, I now have a new piece down here that's also in the bottom of fraction. So now I need to make sure that 1 over x plus 2 does not equal 0. So I need to hash out what that is going to be, and then I can try and clean this lovely junk jazz up. Okay, so I'm going to subtract 2. So I've got 1 over x cannot be negative 2. Now, this is where some students will get a little confused, a little lost. The x right now is tied up under here, so I need to get that away. So I'm actually going to multiply by x on both sides so that I can cancel that part off. So now I've got 1 cannot be negative 2x, and then I can finish by dividing off the negative 2. So now I have x can't be negative 1/2. So now I've picked up another value, okay, for my stuff that is off limits. Notice that I didn't have to work this through, and I didn't try to base it from the original equations because I've got to see how those two things are going to interact with each other, okay? So now let's talk about how to finish this up. So with this one, okay, we really don't like this extra fraction. So kind of the same way that I did this times x over here. What I'm fixing to do with this is I'm going to multiply by an x over x so that I can make this go away. So on the top, I'm going to have 4x over. Now, this does have to go to here and here. So x times 1 over x is going to be 1 plus 2x. Okay. And this is going to be our composition function for this. And then we have a domain of x cannot be -1/2 or 0, picking up both the one that I got from here and the one that I got from there. Okay. So trying to make sure that I get both of those lovely little darlings handled. Okay. And this is one of the more kind of involved ones that you may see happen as far as it has, a couple of fractions in there involved that we've got to work with. Okay. Okay. So now, certainly if we combine functions, compose them, we want to work about decomposing. Now, they make this sound a whole lot harder, okay? And basically what I look for is the nice, easy breakpoint. So if I see a lot of junk, crap, loveliness underneath a square root, then I'm going to let one of my functions be all of the crappy junk jazz stuff that's underneath. And then the other equation is going to be a nice, simple, clean square root. Same thing if I see a fraction and I've got a whole bunch of junk jazz up on the underneath. All that junk jazz up on the underneath is going to be one of my equations. The other one will be a fairly clean and simple equation for that other thing. Okay. So we've got h of x is going to be the square root of x squared plus 5. Now, the one thing that you do need to pay attention to is which order, meaning f of g or g of f, which order they're doing the composition. So for this one, we're looking at they're doing f of g of x. Okay, so we'll bring this back over to our lovely whiteboard here for just a second. So here we've got this. Now, again, first thing I'm going to do is swap out that notation. Okay, so that I can really see g of x is the thing that's inside or being put in. So with something like this, I'm going to lump this entire x squared plus 5 all together. Okay, I'm going to put all of that together, and that's going to be one of my functions. And since that is in that square root, I'm going to let g of x be that x squared plus 5. We got that part. And then f of x is going to be square root, but I do need a variable to show that that was what was underneath it, okay? So now, this is not the only way that you can decompose this. There are other ways. However, I always look for the cleanest, simplest way. So if, for example, I had something like this where it was a fraction, again, I'm going to cluster all of this together. And if I had the same ordering as I did up here, f of x, g of x, g of x would still be that x squared plus 5. F of x would be 1 over. And then I'm just putting an x where I would have put my stuff in. Okay. So we've got that. So that is our combinations and computations. Okay. That is actually the end of section 2.6. So we're going to go ahead and move over to section 2.7. Okay. And for section 2.7, we're going to be talking about inverses. Now, I kind of briefly started the evening by saying that inverses are the things that undo each other. Okay. So, inverse operations are operations that undo each other. So things like add and subtract. If you take a number and add 4 and then take the answer and subtract 4, you end up right back where you were. If you subtract 4 and then add 4, you also end up right back where you were. Multiplication and division, square and square root. There are lots of partner pairs that we have that are inverse operations. Now, an inverse function, so like an equation, is now going to be a function that undoes another equation, okay? So what we've got going on here is we've got f of g of x equals x. Now what that means is when you put and do your composition of f of g of x, you are getting back x. The concept here is if I plug in 3 and I put it into my g function first, got an answer, 5. Plugged 5 into f, I get right back to 3 where I started. If I took 3 and plugged it into f and got -7 and plugged -7 into g and got back to 3, that now happens. But that has to happen for every x, okay? Now, notationally, what is going to happen is f inverse, okay, is this little f with a -1 up as the power. Now, inverses in the math world are like soulmates. You only get one, okay? So we are going to look at, we've got a couple of options for how to make this happen, okay? As this is processing through, and we'll see how these work. So the two methods are, one is called verifying inverses. Verifying inverses kind of like dating. So I've got Fred, and Fred is looking for his math soulmate. He is looking for his inverse. So Fred is going to go out with Susanna, and he realizes that it doesn't work. He's going to go out with Trisha, and he realizes it's not going to work. And then he goes out with Ginger. It's really a trial and error. You're just going to put them together and see if they work, okay? And then we have what's called finding an inverse. And this is what I reference. It's like a match.com. Pick your favorite website. I don't, Christian Mingle, whatever else that you want to do. But this is, you are custom creating an inverse, okay, or that partner pair soulmate for the equation that is provided, okay? So now, looking at the verifying inverses. So this is the dating method. The first thing that you're going to do is you're going to do f composed with g of x, okay? Now, what you're wanting to have happen is you're wanting to get x. When you get done with the process, it should be x, period. Not 3x, not x squared, not x plus 7, not any of that. It has to be plain x. If that happens, then it's a good first date. We're willing to let them keep going. If you're willing to let them keep going, then you're going to do the composition the other way. You're going to do g of f of x. You're looking for x to happen again. Again, plain x, not x plus 7, not x squared, not 3x plus 5. None of that. If at any point when you are doing this, okay, and you've run the process of either f of g of x or g of f of x, if you do not get x, they're not inverses, you stop. There is no reason to go on. If, though, you get through the composition of both and it works out the way that it's supposed to, then one of them will get renamed. Traditionally, f is our main function, so we rename in terms of f. So we would have f inverse would become the name of g of x, okay? So let's take a look at one of these. I'm going to get this down on our board. And we're going to send these guys on a date. So we're going to get these guys on a date. Okay, here we go. Okay, so first thing that we're doing is f composed with g of x. So it's f of g of x. Okay, and I'm going to keep, kind of our process going here. So this is f of x over 3 plus 5. Okay. We'll cover it up again. So f of glasses cleaner is 3 glasses cleaner. Sorry, I got a little small on my writing here. Plus 5. Okay, so 3 glasses cleaner plus 5. So I'm going to get rid and now put in my equation. And now we're going to run this out. So I've got this. So 3 times x over 3. Those 3's will cancel off on that multiplication. That leaves me an x. 3 times 5 is going to be 15. And then I have this plus 5 from the back. That's x plus 20. This is not plain x because it has this extra 20 on it. So these are not inverses. And we stop. Okay, so these are not inverses and we stop. There is no need, y'all, we don't sympathy date. We don't go, oh, well, they were kind of, no, okay? Either it works out or it don't. And if it don't, we move on, okay? We're kind of, cruel, I guess, in that regard, okay? So let me go, we've got another one. So let me go pull, and I'm gonna go ahead and grab that equation without pulling it off my board here. Okay, so I'll get rid of this one. Okay, so we've got f of x equals 4x minus 7, and g of x equals x plus 7 over 4. Okay, so back over here into my meeting. Okay, so here is the next one that we're going to work with. So I've got 4, this is a 4, 4x minus 7, and then I've got x plus 7 over 4. So we're going to start with f of g of x. Okay, and again, I'm just going to go ahead and move it into that process. So we've got f of x plus 7 over 4. Plugging that in, I'm going to have 4 parentheses minus 7. I'm going to go ahead and transfer that. Now, with this one, this entire x plus 7 is all on the top of this fraction. So in this one, the 4 and this 4 will cancel out. So I have x plus 7 minus 7. That cleans up to x. This is what we want to have happen. Now, that does not mean they're inverses. It just says I get to keep going. Okay, so this is good first date. We're going to see if we can keep going. So now I'm going to do g of f of x. So we're going to go the other direction. Try to make this here. So this is going to be okay, and I'm going to fill that in. 4x minus 7. Okay. Now, the set of parentheses here was just a grouping symbol to help me out knowing where to put this. I do have a minus 7 and a plus 7. So now I'm going to have 4x over 4. That is going to give me x. That's what I want to have happen. This now says that they're inverses. So now I would have f of x is 4x minus 7. And instead of having g of x, now that we know that they're soulmates, I'm going to have f inverse is that other equation. So we're not changing the equation. It's still the same that it was before. It just gets a stronger name. This f inverse creates a stronger bond and a stronger connection over to this function by saying it is the one that undoes it. Okay. Instead of it just being, here's a function, there's another function. Okay. So we look to have that stronger relationship there. Okay. So this is the one that we just did. Okay. Now we're going to talk about the other one, which is called finding an inverse. Okay. Now what this one is, this is, we are going to be custom creating, okay, like the perfect fit. So the same way that a lot of those sites do, where you put in all of your information and then it runs all of its stuff and tells you you're having to put in all this information about you like dogs or cats or walks on the beach or the mountains or whatever else. Okay. So what's going to happen with this is if they give you f of x, you're going to change that to a y. And this is just so that we are not having to deal with f of x and an x in the same problem. So we're going to switch it out to a y. The next thing is we are literally going to switch x and y, like quite literally flip-flop them. So instead of having a y equals thing, you're now going to have an x equals thing, and it's going to have y's in it. Then you're going to re-solve that lovely little bugger for y and get y by itself. So we're going to see a lot of kind of peeling the layers of the onion away, okay? Then you will, once you have y back by itself, that will get renamed to f inverse, because again, we are custom creating the equation here that is going to be that soulmate inverse of what's happening, okay? So I'm going to go ahead and get this one written down. So we're going to do f of x is 2 square root of x plus 7, and then minus 3 at the end. Okay. I'm going to work with this one. Okay, so we're back. So now, again, step 1 was change f of x to a y. Step 2 is switch x and y. And guys, quite literally switch them, okay? And flip-flop them, because now we're going to start working with kind of undoing or peeling this onion, okay? So step 3. Now, here's the deal. Up until this point, there's been no math, okay? So if you're going to mess this up, and I hate to say that way, if you're going to mess it up, it's going to happen in step 3, because that's where the actual math happens, okay? So looking at this, the first thing that needs to happen is I need to get rid of the 3 back here on the back side. So I'm going to add the 3. Okay, so I'm going to add that 3 back over to the other side. Now, the next thing is I need to get rid of the 2. So we are going to divide the 2 off. Now, the other thing that's going to happen here is when we're doing inverse working like this, what you're going to see is that I don't do anything like try and do this as like 1/2 x plus 3/2. I'm going to keep it kind of all clustered in those big chunky style pieces, okay? I'm not going to try and work things through or whatever else. We want to keep these in large chunky pieces as this goes, okay? So now we talked about last week that the way to get rid of square root is to square. So I'm going to square all of this and square. And again, this is going to kick off over here. Again, I'm trying to stay out of that glare spot that I've got. Okay, notice, y'all, I am not going to work this out. We are not trying to expand this, bring it into some big long thing. Nope, it's going to stay exactly like that, okay? And the last thing I need to do is get rid of this plus 7, so I'm going to subtract it back over to the other side. Okay, so now I've got y back by itself. So now step 4 is this thing that I have over here, okay? That is f inverse. Now, word of caution. Make sure that if you are having to do this, okay, especially in terms of homework stuff, test stuff, working things out, okay, make sure that you are being very careful with what is in sets of parentheses, not in sets of parentheses, what's occurring after the fact, especially if you had something, say that you were starting with something like this and working back upwards into something like this. You need to be very, very careful about what is underneath your square root, what's not underneath your square root, where that square root is stopping. Same thing with fractions, anything like that. You need to be super, super careful and super, super diligent about making sure that you are putting things exactly where you want them to be as they're processing through. Because not having a fraction bar go long enough or going too long, or having a square root go too long or not long enough. That can be the difference, and it can get very frustrating when you're working through that to try and figure out where is the error in all of that loveliness. Okay, so we're going to go back over to our lovely PowerPoint. Okay. Okay, now with the deal about inverses, okay, we had this thing called a vertical line test. We talked about it back over when we talked about functions, that it was a way for us to look at a graph picture and be able to tell whether or not something was or was not a function. Now, for inverses, we have what's called a horizontal line test. Now, the horizontal line test works very, very similar to the way that a vertical line test works, except that it is a horizontal line. So you're going to be taking a horizontal line and passing it across, okay, a graph picture. Now, what this test determines is if the inverse is a function, not whether or not the inverse exists. Every function will have an inverse. I can make it happen, okay? Everything I can flip-flop. If I'm given a graph, I can make that graph occur. But what I would like to have is we like to have functions so that the original passed a vertical line test. We also would like to have that the inverse, whatever it is, we would also like it to be a function, okay? That doesn't always happen. Sometimes we have a function whose inverse isn't, okay? So what we want to have happen is we want to have, we like functions that have inverses that are also functions, okay? So I'm gonna go ahead and pull, we are gonna talk about how to graph inverses when this happens, and then we're gonna talk about doing a domain restricted inverse. And the whole reason of doing a domain restricted type of scenario is because you have something that the original is a function, but the inverse is not. So then you will do a domain restriction so that you can get that inverse function, okay? So we're going to talk about these two lovelinesses. I'm going to do a quick sketch back over here on my grids, on my whiteboard, and pull this up for you guys. And we're going to talk about, and I'm going to do two things. I'm going to talk about each at the kind of at the same time so that we can see this. Okay, so we've got these two lovelinesses. Okay, so first off, talking about a horizontal line test. Okay, we're literally taking a horizontal line and we are going to pass it or scan it across. Same way as with the vertical one. If I'm ever touching it more than one place, it is not going to have an inverse function. So this one, obviously I've got several spots, okay, where I am touching twice. So not inverse function. Okay, again, that's key to this. It's not that there's not an inverse. There is an inverse, and we're going to talk about what it looks like here in just a second. It's just that it is not an inverse function. Now, with this one, guys, you have to understand, especially down here on this end, this thing has a taper tail, okay? So it is taper tailing smaller and smaller and smaller and smaller and smaller. So as I run my line over, because that little bugger is taper tailing, we don't actually hit twice. I know sometimes when we draw the pictures with markers and stuff like that, it can look like we do get an awful horizontal. So this one does have an inverse function. Okay, so sorry, my clear spot. That one does have an inverse function. Now, the process that we use to graph inverses, I mean, certainly if we have an equation, we can go graph that equation, okay? But if we're not trying to go about that, okay, the way that we process finding an inverse function, okay, is we switch our X's and Y's, okay? So I'm going to use, I didn't realize that was all I had on that page. So I'm going to stop this, okay? So here's the way this works. You're going to flip-flop your X's and Y's, okay? Now, if they give you ordered pairs, that is great and wonderful, okay? So let me make some little notes here. So to graph an inverse, okay, if you have X, Y as an ordered pair, y comma x is on the inverse. So this is part of the inverse. Okay. Now, sometimes you're going to have graph pictures like this, and it's not as obvious being able to find ordered pairs and stuff like that. Okay. The other thing that you can do is reflect over the line y equals x. Okay. And I'm going to show you what that looks like. Okay. So if I've got a grid space, the line y equals x, and I'm going to do it dashed here, is the perfect diagonal that runs through quadrants 1 and 3. Okay. So it's the one that runs through quadrants 1 and 3. So now I'm going to go back up here and I'm going to play with these two. I'm going to go ahead and mark where that line is. Okay. Where this dashed line is. And then we'll talk about and see where this comes through. Okay. So I'm going to come back up. Okay. So for this one, okay, so if I look at this first one, if I'm going to reflect, okay, and it is kind of an odd diagonal reflection, this piece right here is going to reflect to here. And this piece, since it's on the line, is actually going to just be its own reflection. Now, if we notice the purple, which is the inverse, fails a vertical line test, which means the purple is not a function. But we already knew that because of the horizontal line test. Okay. So now with something like this, okay, so I can kind of see where this is arcing out away. So I'm going to create something that arcs kind of out away. And then this stays just on top of that line. So I'm going to make sure that I stay just off of that line. So there is what the inverse looks like for that one. And again, this has got a taper tail. It's getting closer and closer and closer and closer, but never actually goes there. So that one will pass a vertical line test as it's processing. Okay, so that one still has that it's an inverse function. Okay. Now, that is the end of section 2.7. Okay, so we're moving right along. We're doing quite well on our time. So now we're going to look at 2.8. Okay. And 2.8 is our last section that we've got to cover for the night. So I don't anticipate that we're definitely not going to be going all the way until 8:40 tonight. And I realize part of that is in part due to the formatting of this. I'm not there to kind of watch and gauge y'all's reactions to stuff the way I can in a classroom. So I'm just kind of processing. Okay. So we're going to deal with distance formula, the midpoint formula, and then we're going to talk about circles. Okay. So first up is the distance formula. Now, the thing here about the distance formula, and I'm actually going to show you where this comes from as a process, just so that you're aware, but it also gives you another option for how to work through this, okay? So the distance formula is you're going to have 2 points, an x1, y1, and an x2, y2. And so you wind up subtracting your x's and then squaring that quantity, and then you're going to subtract your y's, and you're going to square that quantity as well. You're going to combine those with addition, and then you're going to square root that, okay? So the particular pairing that we're going to be looking at as we're processing through this, okay? And the wording down there on the bottom is just if you're going to try and say what this looks like in verbiage, okay? What it looks like. This is one, again, after I show you the process for this, you will have kind of two options. You can either work with the formula or you can work with a visual for how this is going to work out. So we're going to be working with the points -1, -3, and 2, 3. Okay. So let me swap out. Okay, now let me explain where the distance formula came from, okay, before we get on to our specific example over here. So what happens here is they had a point and they had a point and they wanted to hash out what this distance between the 2 points was. Okay, so what they actually did is they created a triangle. Okay, and the thing that we know for a triangle is we know a squared plus b squared equals c squared. We know our Pythagorean theorem because we do know that this is a right triangle, because we know that this is a horizontal and a vertical line. And when we talked about lines, we know that vertical and horizontal lines are perpendicular to each other. So if we're going to call this down here A, okay, the way that I would do this is I can either count the number of squares or I could subtract these two x values from each other. Notice that's what's here, okay? So we would have A, and again, that came from a subtraction thing, squared, okay? Now then, if I played the same game with the y's, so I'm going to call that B, I could take this y and this one, and I could either count the number of squares that it had, or I could subtract the y values, hence what they're doing here, and then I would have to square that. Now, that's going to equal c squared, but I don't want c squared, I only want c. So the way that we would handle that is I would have square root of a squared plus b squared equals c. And again, the fact that I've got a could be found by subtracting the x's and b could be found by subtracting the y's. That is a really bad y1. I'm sorry, y'all. That's a y1 up there. Then we have this. So I'm going to show you the option of how to do this problem using, first off, this visual way to do this, and then I'll show you how to do it with the formula, just so that you have those two options. So I'm going to start by graphing the two dots. So I'm at -1, -3. And I'm at 2, 3. So I'm going to connect them. I'm going to come down and across. Now, you could also go up and over for this one. That's kind of doesn't matter. So here I've got, if I'm counting 1, 2, 3. So this bottom edge is 3, or has a length of 3. If I'm going up the side, I've got 1, 2, 3, 4, 5, 6. So I have a distance of 6 up the side. So now doing 3 squared plus 6 squared equals c squared. I'm going to have 9 plus 36 equals c squared. Add, I'm going to get 45 equals c squared. Again, I don't want c squared, so I'm going to take square root of 45. Now, with this one, we don't have to do plus and minus because you cannot have a negative distance, okay? So you can only have a positive distance. So we're just going to need to do the square root of 45. Now, if they're asking you to keep this in clean, kind of that rationalizing, I can break 45 as 9 times 5. Square root of 9 is 3. So I have 3 square roots of 5 equals c. The other option is that you could actually work that down to a decimal value. Okay, by just doing the square root of 45. Okay, so square root of 45 is 6.708 if I do it in decimal. And guys, all I quite literally did, so if I can bring this up, is I did square root of 45. Okay, so if they ask for it in decimal, you can just run it out on a calculator. Okay, if they ask you to simplify it, we've got it there. Now, let's talk about what this would have looked like in our pretty little formula. Okay, so x2, which was 2, minus x1, which was -1, squared, plus y2, which was 3, minus y1, which is -3, squared. This is going to be 2 plus 1 squared, plus 3 plus 3 squared. That's going to be 3 squared plus 6 squared. Guys, notice 3 squared plus 6 squared is the same thing that I had up over here. Okay. That's going to be 9 plus 36, which is the square root of 45. And then we're right back over to that portion where we were over there. So this is one where it truly doesn't matter to me. Some of my students are more visual and they like this idea of being able to have the visual there to see it. Some like to just cry. So let me share. Let's get back to our PowerPoint. Okay, so the next thing that we're going to look at is midpoint. Okay, and guys, midpoint is literally the halfway point between the two points that they give you. Okay, and so the way that you're going to do this is you're going to add your x's and divide by 2. So you're basically averaging the x's. And then you're going to also do the same thing with your y's. You're going to average your y's and do this. Okay, so I'm going to bring up this one as well. And then I'm going to show you one thing that they may do with this midpoint thing that, again, I do slight bit different than they do. So we're going to be working with the point 1, 2 and the point 7, -3 when we get over here to work with this. Okay, so bringing back our lovely board here. Okay, so we're going to take 1 plus 7 over 2, and then 2 plus -3 over 2. That's going to give me 8 over 2, -1 over 2. And then cleaning the last of that up is going to be 4. And I would just leave that as -1/2. Okay, so and midpoint is quite literally that straightforward. Okay, it is quite literally that straightforward on. Okay, now the only other thing that I have ever seen done, okay, is going to be that they give you an endpoint. So let's say that our endpoint is 3, 6, and our midpoint is 7, 1. Okay, and they ask you to find the other endpoint. Now, lots of and I'm sure if you do like show me an example or whatever else, they're going to try and plug this back up into this lovely formula up here. That's just not how I do it, y'all. What I do is I write my endpoint and my midpoint, and then I'm going to work to find the other one. So the way that I do this is I ask myself, how do I get from 3 to 7? And in order to do that, I need to add 4. So then you're going to do that same process again. You're going to add 4. So 7 plus 4 is going to give me 11. Okay. And then we're going to do the same thing over here. How do I get from 6 to 1? I've got to subtract 5. So we're going to do it again. We're going to subtract 5. So 1 minus 5 is going to be -4. So my other endpoint would be at 11, -4. And you can run 11, -4 and 3, 6 back through your formula, and you can determine that that does in fact give 7, 1 as the order of pair. I use the concept here of if Tyler is the midpoint between Dallas and Shreveport, If I have to drive 100 miles east from Dallas to get to Tyler, then I have to drive 100 miles east to get to Shreveport. Okay, so I use that as the concept. Now, the last thing that we've got to cover is circles. And working with the circles, we will have to do, there's a little bit more, okay, that we've got to do with circles. Now, first thing is, I'm not changing what it means to be a circle, okay? A circle is, and they make a formal definition, a circle is the set of all points in a plane that are equidistant from a fixed point called the center. The fixed distance from the center to the point on the circle is called a radius. There are two forms. There is what's called standard form, which is x minus h squared plus y minus k squared equals r squared. There is also the general form of a circle, which is basically kind of like a multiplied out. Now, the thing is, we need to be able to work in standard form. Standard form allows us to know exactly where the circle is located. Now, one of the things that you need to understand is in the math world, when we use sets of parentheses in a graphing setup, okay? When we use parentheses, it means to do the opposite of what we think. So when we have this x minus h, if you see, so first off, the x's is going to handle the left and the right. Every circle begins its life centered at the origin, so at 0, 0. So if I have x plus 2, normally my brain says plus should be to the right. It's actually going to go to the left. It does the opposite of what we think it should do. So x plus 2 would actually take that circle and shift it 2 units to the left. Okay. Now, if I had x minus 5, again, our brain normally thinks minus would be back off to the left. It actually moves to the right 5. So it's going to do the opposite of what you think it's supposed to do. Also, though, we have the y minus k is also in a set of parentheses. So it's also going to do the opposite of what you think it's supposed to do. If you have y plus, now y is our up and down, y plus 4, normally we would think plus is up. It actually moves it down 4 spots. And if I see y minus 7, instead of going down 7, it's actually going to go up 7. Now, one of the things that we will have to look at here in just a bit is how to get from general form of a circle back over to standard form of a circle, okay? So first off, we're going to talk about how to write this loveliness in standard form. So we have a center at 0, -6, and I have a radius of 10. Okay, so I'm going to switch over here. Okay, so here we go. Okay, now, first thing I always like to do is get myself just a little grid space and let me see how this is going to work. So my center, normally, again, I always start here at 0, 0, and I'm going to go down 1, 2, 3, 4, 5, 6. And that's now where my center is. So I know that the whole circle moved down 6. Now, when you do this on Math Lab, if they ask you to graph a circle, you're going to click the little circle grapher, and you're going to have to click 2 points on your circle. The first one is going to be this one that's your center, and then you're going to have to click 1 spot on the outer edge of the circle. So I have to do something with this radius of 10. Now, if it was this one, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'd put my little dot up here. I would also go out 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be up here at my edge. And then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I would have down here. And I'm going to freehand this, and it's probably going to be a really crappy circle. Okay. But this is now that circle, okay? On Math Lab, you would only have to put in this point and one of those 4, okay? Now, to get this into our lovely little equation, though, okay? So bringing this back. And again, noting that it went down 6, okay? When I start to think about This was X. This was Y. And then this is R squared. Okay, so I've got a squared over here. I didn't go left or right any. Okay, so you can either put a plus or a minus 0 on that one. But I did go down 6. Now, normally my brain says down is minus, but I do the opposite. So that's going to be a plus 6. And then my radius goes over here. Now, you don't actually have to write X plus 0. So you could clean this up to X squared plus. Now, at this point, if they want it in standard notation, you're probably going to have something that looks like this. Okay. X squared plus Y plus 6 squared equals 100. Okay. This is going to be what we're seeing and what's processing. Okay. They usually don't have you actually push this out to that general form where you actually have to multiply this out. Most of the time, we're going to be working from that general form and trying to bring it back to standard form that's going to look like this. Okay, so let's go back to our PowerPoint. So it says use standard form to find the center and the radius of the circle whose equation is this. Okay, so I'm going to write this down. And I'm going to do this in 2 parts. I am going to go ahead and plot the dots. I'm actually going to state the center. I'm going to state the radius. I'm also going to show you the drawing, okay? Because oftentimes they will ask you to go ahead and do a drawing as well when this processes, okay? So I'm going to get our equation down. So here's our equation. So here's my grid space, okay? Now, again, okay, this has got to do the opposite of what we think. So plus 3, my brain normally goes should be to the right. It actually is going to go left 3. I see Y minus 1. I know that the Y's is my up and down. So I normally think down is the negative. This is actually going to go up 1. Now, the other thing is, please remember that this is R squared. Oh, that color did not show up well. That is R squared, which means R in this one is 2. Okay, because R squared is 4, not R is 4. Okay, please keep that in mind. So in order to graph, okay, and I usually do go to a graph so that I can go ahead and handle my center. I'm going to start right here at origin. Sorry, it's better. I'm going to go left 3 and up 1. This is now my center. So I can go ahead and locate that at -3, 1. So that's my center. And again, if I had to graph, I would go right 2, up 2, left 2, down 2. And then play connect the dots and make a circle. Again, Math Lab will have a lovely, pretty little circle creator. You only have to spot the center and then one of your 4 cardinal ones, and it will automatically build that graph picture as it goes. So my radius was 2 and my center was at -3, 1. Okay, so go back to our PowerPoint. So now, the next thing that we've got to do with circles is, and I've mentioned it before, is we've got to do getting our thing from general form, which is that X squared plus Y squared, and it had a whole bunch of other stuff back behind it, back into that X minus H in a set of parentheses squared plus Y minus K in a set of parentheses squared equals R squared, okay? So the way that we're going to start this is you're going to get all of your X terms near each other. You're going to get all of your Y terms near each other. And then that plain number thing, you're going to get moved over to the other side. Then you're going to have to do the complete the square process that we talked about last week out of section 1.5. We're going to have to do that twice. We're going to have to do it once with the X's, and we're going to have to do it again with the Y's, okay? And the same way that we saw last week, where we had to make sure that whatever we added on the left, we had to make sure to add that on the right. this time we've got to make sure that we do it for both items that need to get processed through, okay? So I am going to utilize some color here just to make sure that we can see and process everything that's going about as we go through with all of this, so that you can see everything that's going on, and then hopefully not get lost in the loveliness, okay? So this is going to be the one that we're working with. So I'm going to go ahead and get this one again written on our whiteboard. I kind of wish they wouldn't have picked 4s for everything, but it'll be okay. Okay. And so now we're going to get this lovely little darling into standard form. Okay. So let me see. Oop, sorry. Let me get my lovely little screen back up here. Oh, there it goes. Okay. So first things first, I've got to get my x's near each other and my y's near each other. So I'm going to do x squared plus 4x plus y squared minus 4y. And then that minus 1, I'm going to add to the other side. So it's going to be a positive 1. Okay. Now, I'm fixing to do my little complete square process, and I'm going to do it over here off to the side. Okay. So remember that it was, I take the number in front of the x, so the b term. So in this case, it's a 4, and I'm going to divide it in half. So now I'm going to get 2. Then we're going to square that. And again, I happen to get 4 for that one. That's going to give me x squared plus 4x plus 4, which we know will factor to x plus 2 squared. Okay, so there it's done with the x's. Now I'm going to do my y's. So first thing is I'm going to take negative 4 and divide by 2. So I get negative 2. I'm now going to square that. And I get 4. We now have y squared minus 4y plus 4. And that will factor to y minus 2 squared. Okay. Now, same as we did before, I need to get this chunk, this x squared plus 4x, to look like the stuff in line 3. So I'm going to have x squared plus 4x, and I'm going to do plus 4. So I'm adding that 4 that I had on that line. Okay. Then I'm going to have y squared minus 4y. This one was also a plus 4. So I'm going to have plus 4 equals 1. Now again, I can't go putting stuff on one side and not putting it on the other. So I'm going to put both that purple 4 and that red 4 over onto the other side. Now, this group, we know factors to x plus 2 squared. We know this group factors to y minus 2 squared. And then combining 1 plus 4 plus 4, I get 9 over there on the other side. So if I had to go graph this, again, this tells me, normally I think plus is right. So I went left 2. Normally I think minus is down. So I went up 2 because again, it's opposite. My radius is going to be 3 for this one. So I'm going to left 2, up 2. There's my center. And I'm going to go 1, 2, 3 up. 1, 2, 3 to the right. 1, 2, 3 down, and 1, 2, 3 to the left. And I can form that circle. Okay. And that's how we convert out from general form to standard form. Okay. Now, that is also the end of section 2.8. So we are done for the evening. Now, thing to note, and I will put an announcement for this in Math Lab or not Math Lab, Canvas as well. we are going to have a test next week over the material that we covered. So section 1.5 and 1.6, and then over 2.6, 2.7, and 2.8. So you will see a review open up in my math lab. That is a test 2 review. Keep in mind that that review is optional. It is not for a grade. It does not count in any way, shape, form, or fashion towards your grade overall. Excuse the dog in the background, please. And so you will have the ability to access that for that review. We will still have the 45 minutes at the start of class to go over topics and then ask questions, and then we'll have the test as it was before. So if you've got any other questions, I'll be on here for just another couple of minutes. I am going to switch it back off to where I don't have the whiteboard running, to where it's just me. And so if you have any questions, I can stick around and answer those. If not, I'm done with y'all. Thank you so much for being understanding about my inability to be at the campus tonight. I do appreciate it. Okay. Okay, I'm back over here on this side now. Okay.